Welcome to the Automotive Diagnostic Podcast. We're going to explore ways to sharpen our diagnostic skills, find learning resources, and hear from experts in the automotive field. I am happy to have Automotive Seminars as a sponsor for the show. Now, if you're not familiar, Automotive Seminars is a diagnostic technician training company. They've got a website that there'll be a link to in the show notes. And what they offer is top-notch training to technicians like us in the field. I've been taking their training courses for years and have got a ton of benefit out of it. They've got top-notch instructors, John Thornton, Scott Shotton, Scott Manna, and every other month they've got a 2-night course that you can sign up for. Join in, ask questions, and afterwards, you've paid for the course, you can access a recorded version whenever you want. You can rewatch the class 2 years later in case you wanted some details on it. And that is a fantastic feature. So make sure to check out the website to see what courses they have available and what's coming up in the future. This episode is brought to you by L1 Automotive Training and Keith Perkins. If you're looking for education on module programming, J2534, EEPROM work, key and immobilizer, electrical diagnostics, or drivability diagnostics, Keith has a website, l1training.com, that's got over 60 hours of training videos on all those subjects and more. When I first started out doing mobile, I utilized Keith's videos on module programming in J2534 in order to get my head wrapped around what I would need for the tooling, the computers, the software setups, what kind of obstacles I would be up against when I'm out there programming modules on cars. And it was a huge benefit to me. And I continue to use the training videos that he has on his website. So I strongly recommend checking out l1training.com. The link is in the show notes. Hey, what's going on, automotive world? Welcome to another episode of the Automotive Diagnostic Podcast. My name is Sean Tipping, and I'll be your host once again for today's episode. Thank you so much for joining me. I've got a couple case studies for you here today. Before we get into that, I wanted to let everybody know a couple things. Number one, we do have some merch available for the podcast, sweatshirts and t-shirts. The sweatshirts are in a limited supply, but we can order some more. The t-shirts we have plenty of, but I also want to give everyone a chance to win a t-shirt for free. So here is all you have to do. Leave a review on the podcast with Apple or Spotify, or leave a comment on our YouTube channel. And if you're not aware, we've been doing some video overlays for not only the interviews, but also these case studies. I have PowerPoints that walk you through the case study along with the audio. Now, my goal is to make the case study so that you could just listen to it and you'll get everything that you need. You don't require the visuals. And that's the way I've always done it on the podcast. Sometimes that's challenging to describe something without a picture or video, but there is a video available on YouTube. So check that out. The link will be in the show notes. But anyways, all you have to do is leave a comment or a review for the podcast, and you'll be entered to win a free t-shirt. We'll announce that once a month on the podcast. So listen for your name, and then we'll get that t-shirt sent out to you. But that's what I got for you there. Let's get into the actual case studies. Two vehicles here. Oddly enough, these were very closely related in what we found wrong with the vehicles. And it was a similar scenario, and strangely enough, it was on the same day. I think there was one stop in between these two vehicles, but they ended up being very, very similar to each other, which is weird how that happens, but it does seem to happen in our world where we'll get waves of stuff or back to back of the same problem. And I mean, these cars are pretty unrelated. It's not like a pattern failure. But anyways, what we're dealing with is a 2015 Chevy Impala and a 2017 Ford Escape. And again, both of these are going to be very similar, but we'll get into it here. Both of these vehicles had used engines installed by the shops. And again, these are separate shops, different technicians, different places, but similar situations. And both of these engines do not start after the engine installation. Okay. And, we get that a fair amount is a shop will install an engine and there's a million things that can go wrong, including wrong parts, right? Those escapes in particular, man, you got to get the right engine on the 1.6s. If you get like 1 year off, they'll have coolant temp sensors that don't exist in the cylinder head for 1 year to another. And those things will tell you, hey, it's overheating and go into like a limp mode. And you're not going anywhere if you get the wrong engine in those things. So you really got to pay attention. And that's one of the things that we see is the wrong engine being installed. Or if it's a used engine, it might just be bad right off the bat, right? Especially the motors that we're going to be talking about today, an EcoBoost and a 3.6 in the GM. I mean, the chances of the used one having timing issues are likely, but you can also have a lot of man-made issues along with the engine installation. So anyways, we get calls on stuff like this a lot. And the shops in a lot of cases have decided that we've got a lot of other work to do that is profitable and we can keep our tech on rather than having him spend hours and hours of his time to figure it out and not producing elsewhere in the shop. Now, I mean, hey, for the technician that's doing it, would it be beneficial for them to actually go through all of this and figure out where the mistake was? Yeah, I definitely think so. But anyways, that's the service that we offer and the decision that the shop has made. So we're going to dig into it. We're going to figure out what's going on. So we're going to start with the Impala because that was actually my first stop. And I always talk to them and try to get as much information as I can. I want to know, hey, what did the engine come out of? Are you sure it came out of the same vehicle? Do you have the VIN number? And a lot of times you can, depending on where you're ordering it from, you can get the VIN number of the vehicle it came out of, right? So we want to match that up. And he didn't have the VIN, but he was pretty certain it came out of the same year Impala. Okay, cool. I also asked, did it run before the engine swap? Right? That's definitely a question I want to know. Or did it sit for 5 years before the engine swap? These are some things I want to know. This one did run beforehand, but it had a rod knock. The tech also tells me, because I'm talking to the technician that did the work, that the engine ran for a short period of time after he put the engine in, and it seemed to run pretty well, but he backed it out in the parking lot and was going to take it for a test drive. It stalled. It wouldn't restart. He said it popped a couple times, like you could hear some cylinders hitting, but it never started back up after it had run for the initial first few minutes. And now it's just a crank no start with nothing going on. So that's where we're at currently. So when I'm in a situation like this, how am I going to approach this? Because I mean, honestly, it'll be different if I'm the one that performed the work, right? And I installed plenty of used engines or engines in general when I was a technician. And if it's my job, I can go over things a little bit differently because I have in my brain what components I put on the vehicle, right? And I would try to pay attention to engines as I have them out of the vehicle, right? Before I put that new or used engine in, I'm going to compare everything, right? Because you can have weird stuff like the timing cover is different because they didn't get it out of the exact same vehicle. Things like the flex plate, if I take this off, can I put it in any which way position like a Nissan, or does it only go on one way? Sensor differences, tone wheel differences, electrical connectors, harnesses, all these things you want to pay attention to. And ideally, the technicians would have, and I would have, but you miss stuff, right? Anyways, what I'm getting at is I might approach one of these vehicles differently had I done the work, but coming into it fresh, I'm going to take a slightly different approach. Now, I do want to consider
the potential man-made factor. And there's a good likelihood that something the technician did or didn't do caused the no start, but maybe not. Maybe they got the wrong part. Maybe it's something unrelated. Maybe it's a pre-existing condition, right? So I used to tell my students this when we would do we would bug vehicles at the college, and it would be like a diagnostic challenge for them to figure out what's wrong with the vehicle. And when I would bug these vehicles, I would really try my best to set them up like a real life failure, which is actually way more difficult than you think. Try to break a car and have it exhibit the symptoms that you want it to exactly like a real broken car. That's tougher than you think. But we would do that because we want them to have, a real broken car like they would out in the field. Of course, nothing mimics an actual broken car. And I actually liked it when I didn't know what was wrong when we were working with the students. But for specific areas and subjects that we were covering, we would, have certain bugs in the vehicles. But, anyways, what I'm getting at here is what I would tell the students is when you go into this and you're trying to figure out what's wrong, don't have at the front of your mind, what did Sean do to the vehicle? Just take your normal process and let your tests guide you. Think of this as an actual broken car, because I saw so many times the students would get into it and they're just looking for what I did, or they're thinking, well, Sean wouldn't have gone to this measure to break this thing or install this component. But again, I try to make it as real as possible and I put some effort into it. And when they had in their heads that they were just looking for what I did and not really testing, not treating it like a real car, real broken car, they'd struggle and they go in circles and they'd have a really tough time with it. But the same goes for me when I'm out in the shop doing this is, yeah, I do want to consider that it could be man-made, but I don't want to overlook the possibility that it's something unrelated or something pre-existing. So I want to let my tests guide me to the solution. And I'll keep in the back of my mind that, hey, maybe the tech screwed something up. So first thing, of course, we're going to do a full vehicle scan. I got no codes in the ECM, nothing, and no other codes in the car that point me to any reason why the vehicle might not start. Of course, when I look for like an anti-theft situation, I didn't see that. So I'm still on the scan tool and I want to look at some important data PIDs for starting a vehicle. And depending on the vehicle you're working on, these are going to change or different ones will be available, not available. But the things I want to look at, the basics right off the bat, is engine RPM, right? The cranking speed shown in the scan tool, read from the ECM off of the crank sensor. I want to just, is there RPM? Obviously, that's a good place to start. If you don't have that, the engine's not going to run. I want to look at fuel pressure. This is a GDI engine. I can see the high side pressure. I want to see that. Temperature sensors, right? Coolant temp, intake temp. Just make sure those are plugged in and reading correctly. This is a mass airflow sensor engine. So I want to see as I'm cranking, what's the mass airflow sensor doing? Is it doing anything? What's it reading? Camshaft data PIDs, if I have them, right? And on this 3.6, I actually do have some camshaft data PIDs that can be used even during cranking, because that's one thing that I'm considering is, hey, this is a 3.6. It's really common for GM 3.6s to have timing issues. What's the likelihood of a used engine has a timing issue? Very possible. I've even seen on these 3.6s after an install where there's damage to the camshaft sensors. I had one where the tech swapped over the sensors and they somehow damaged the sensors. I don't know if they hammered them in or what happened, but they weren't reading correctly and it wouldn't start because of that. So I'm going to look at those data PIDs, and that's not going to tell me everything, but it might lead me to a point where I hook up a scope and see what's going on. And the last thing is the anti-theft status, to make sure that the engine is allowing fuel to go into the engine. And those are kind of the basics of what I want to look at. Now, there might be more depending on what I find or what direction I go, but this is going to kind of give me a base of like, hey, what's going on with this thing? And it might be as simple as, hey, maybe there's no fuel pressure, right? So my RPM's there. It's about 200 while the engine's cranking. My fuel pressure on the high side is about 1,000 psi after cranking for an extended period of time. Now, interesting thing on these 3.6s, because I have just dealt with a lot of no starts on these, is they don't need like full high side pressure in order to start and run. And one reason I know this for sure, and I was kind of thinking about this, although I didn't think this would be my problem, was when techs do motor swaps on these, they'll change over the high pressure fuel pump in a lot of cases. And there is a fouler, a roller that goes between the high pressure pump and the camshaft on the back side of the front head. And when they swap over the high pressure fuel pump in a lot of cases, they forget to take this roller out and move it over to the other engine. And if you do that, no motion is transferred from the camshaft to the high pressure pump. And the car will run on low side pressure, but it won't build any high side pressure. You'll get codes. You have really low power. You can't accelerate, all that stuff. It's a GDI engine. It can't run on the 60, 70 PSI that the low side generates. So, but again, I'm going over that just because it's something I run into on these. I'm not really considering that's going to be my problem because I know that these engines will actually start on low side pressure. But that's a good thing to know, right? Because if I were to see this thing cranking and I didn't see high pressure fuel getting built up, I'd ask myself, well, is it because it's not building high side pressure? On these 3.6s in particular, I can't say this for every engine, but on these 3.6s, they will start and run on low side pressure. But again, after I cranked this thing for quite some time, I was building up a decent amount of pressure. I got fuel pressure. That's the the short of that long story is I have fuel pressure. My temp sensors are reading about room temperature, which is what I want to see there. My mass airflow is reading about 3 grams per second of air while I'm cranking. And I don't know what value is good right off the top of my head for cranking 3.6, but it's moving some air, and it seems to be approximately something, a range that I would like to see. I don't see an issue with that number. The camshaft data PIDs are counting, and you can see there's a camshaft counter, and then there's also a camshaft RPM data PID for this vehicle, and it's reading the same RPM as the engine. Now, does that mean everything's in time, everything's perfect that way? No, not necessarily, but I know that the computer is getting a reading off of both of those sensors, and that's a good step in starting the engine, right? Is inputs for more cam and crank. We have that based on the scan tool. And then the anti-theft status is allowing fuel. So based on the scan tool stuff, I don't really see anything that's, glaringly obvious about this vehicle or this engine not starting. While I'm cranking it though, I am going to do an audible check of the engine. And what I mean by that is anytime you have a no start and really anytime you have a misfire on an engine, you should do an audible check of the engine cranking, right? Do that clear flood or disable fuel specifically, or spark, and listen to the engine as it's cranking. Now, I don't have to disable anything on this one because it doesn't start. I can just listen to it. And I'm not so much listening for a single cylinder that's on low compression. That would be more of a misfire, but the engine as a whole, how does it sound when I'm cranking this over? And all of us technicians, we've heard a ton of engines. Now, from engine to engine, of course, the sound is going to be a little bit different. It should be very rhythmic across the board. There shouldn't be a big increase or decrease in speed, but we kind of know what an engine should sound like cranking. And I've heard enough of these 3.6s where it sounds okay. Now, we do want to be careful with a test like this. We have a lot of tests like this where it's going to tell us some information if it fails, right? If this test fails, like I hear an obvious compression issue with the engine, I know I've got to go that way. I got to start looking at timing, or in a misfire situation, I hear that that speed up of the crank when it hits the dead cylinder. I know for sure I've got an issue. No question about it. But if it just sounds okay, that doesn't necessarily mean that there's no problem. And so we want to be careful of tests like this that can give us a false negative, right? And that would be, so if I am testing for something, imagine you're testing for COVID, right? And you the test came back positive. The thing you were testing for, it came back positive. You have COVID, right? And in this case, I'm cranking over the engine. I'm listening to it. I don't hear any compression issues right off the bat with my ear. And so it would be negative for compression issues, right? That would be the result of the test, is a negative test result for mechanical compression issues. But that doesn't necessarily mean that there are no compression issues with the engine, specifically timing in this case, right? The timing could still be off, and my ear is just not tuned enough to pick it up in this case. And we have a lot of tests like that, right? An ohm meter is a great example of that. If you test a wire and it's OL, it's for sure bad, right? If that test comes back as a positive result, it's OL, you've got a problem. But just because it measures no resistance with an ohm meter doesn't mean that that wire is necessarily good, right? It may not be able to handle a load. And this all goes into understanding our test methods and what they can tell us and what they can't tell us, like knowing the limitations of our test methods. The blue fluid you use for head gasket leaks into the cooling system. That's another one, right? That fluid turns yellow, you know you have a combustion leak. It's an end of story. But if it stays blue, that doesn't necessarily mean that your head gasket is 100% good. You could still have an issue, right? There's so many tests like that out there. And it doesn't mean to not use them, right? Just because my ear can't do an official compression check on the engine and verify timing doesn't mean I'm not going to listen to it and take that piece of information, but understand the limitations. So where I'm going with that is just watch out for like false negatives on tests and understand the limitation of whatever test method you're doing. But that ear check, I'm going to do that. And I did it on this one and it sounds okay. So again, long story there, but I was just thinking about that as I was making this presentation about these tests that don't necessarily tell you that everything's 100% good if it passes, but if you failed the test, you know for sure there's an issue. Okay. So at this point, I'm kind of done in the car on the scan tool. I got to go to the engine, start doing some tests, right? Let's see what we're missing. Air, fuel, spark. It's got to be missing one of those. Let's find out. So I want to pull a spark plug on this one. And I want to do this for a couple of reasons. Number one, I want to see on the spark plug, do I have fuel? Is it wet? And I was kind of smelling for fuel as I was cranking. I didn't really smell any, but I wanted to see, is there fuel in the cylinder on the tip of the spark plug? And this will also allow me to check for spark at the same time, right? Because I got to pull a coil out to get to the plug. If depending on what I find on the plug, now I can test coil or the spark out of the coil. All right. So this is going to do a couple things for me. So the spark plug's new, number one. They put in new plugs when they did the engine, which makes sense. I did that too as a tech. It is wet and it smells like fuel. So I can assume at least some fuel is getting into the engine. I don't know if it's enough or the right amount or at the right time or any of that stuff, but it looks like there's fuel getting into this engine. So what I'm going to do next, because I have the coil out, is do a spark test. And the way that I do a spark test is just with my incandescent test light. Don't use an LED one. It'll fry the LED components inside your test light. But incandescent bulb test light is a great spark tester, because what you can do is just clip the little clippy end to ground anywhere. Heck, I found you can even do it to the positive side of the battery, but clip it somewhere on the ground, on the block, on the battery, wherever, and you're going to hold your test light. Now make sure you hold it on the plastic part, not the metal part. Hold the test light up to the coil and have someone crank it over, or you can get creative and crank it over yourself and just watch to see, does the spark jump out of the end of the coil? So I do this and I don't see any spark coming out of this coil. There's nothing. I'm like, oh, okay, well, we're on to something. We don't have spark. We appear to have fuel. Let's follow this, right? We're in a funnel now. Let's find out why I don't have spark coming out of the end of this coil. So let's do some checks at this coil that I'm at and see what we're missing. So I should have B plus into one wire straight from a fuse from the battery. I should have ground on two different wires. And then I should have a 5-volt pulse from the ECM while I'm cranking or the engine's running. And So this is a coil where there is a transistor inside, and the ECM is just going to send a small 5-volt signal to this coil in order to spark, and then the coil handles the load of that primary coil, right? So the computer, the ECM, doesn't actually have to handle all the amperage of that coil. That happens all within the coil, and it just gets a signal. So again, I'm just looking for power, a couple grounds, and a 5-volt pulse. And what I find is I have all of that. And I was using my test light to measure the B plus to the coil and the 2 grounds. And I was using my U scope to measure the 5-volt pulse while the engine was cranking. And I seem to have everything there. And I'm like, well, okay, it was a dead coil. I'm like, that doesn't make any sense. How could they all be dead? Let me move one over and I'll do the same checks. I just want to see, because everything that showed me on that first coil, I was on cylinder 6, which is, this is a transversely mounted 3/6, if you can imagine that. So cylinder 6 is the driver's front corner under the hood. And so I move one over to 4, which is the middle cylinder of that bank to the front bank on this engine. And I'm just going to do the same check, right? So I put my test light in the same manner up to the coil. I crank this thing over. I have no spark out of this one. I'm like, oh, this is weird. But this time, and I had the tech cranking over the engine for me, I take my test light and I move it inside the boot of this coil, because where I usually put the end of my test light, the tip of my test light, is going to be just outside of the boot. And under atmospheric pressure, any coil, especially on a modern engine, should be able to jump 3/4 of an inch easily. You should hear a snap, see a bright blue spark out of there. I don't have that, but I move it closer and closer and closer as he's cranking. And I get it where I'm maybe an eighth of an inch away from the actual metal part inside of the coil that normally is on top of the spark plug. And I see a little tiny blue, I don't even know if I call it a spark, but I see something, a little arc in there when I get my test light right up against that metal. So it is sparking. And same thing on the number 6 coil as well. So it's a very weak spark, but it is there. And at this point, I kind of know what direction I need to go. I need to load test the powers and grounds to this coil, to all of the coils, to see what's going on here, because it's getting its signal. And I tested the B plus and the ground using my test light, but I need to put some actual load on these circuits and see what I'm missing. And so I do that with my headlight bulb, right? 9,000 series headlight bulb. You're going to pull 4 amps with this thing, or at least the one that I'm using. And I test my power. So I have ground on the other side of the headlight bulb. It's good, but I test the ground to the coil. So I have B plus on the other side of my headlight bulb, and it does not light. And I verify, I move the lead of the headlight bulb over to the other side of the battery. It lights up, cool, but I don't have it on the ground on pin A going to this coil. Okay, so now we're on to something, right? That ground path was enough to make a little tiny spark, but probably not enough under compression. And it was enough to light up my test light, but it was not enough to light up this headlight bulb. So I've got a ground issue here, and the engine was just installed. So now we're coming back to, okay, technician fault maybe, but my test led me to this point. I didn't just start looking for grounds that were disconnected. Okay, I could do that. I could do a visual inspection. I don't think I would have seen this problem, but now I know for sure where I need to go. I just got to find this ground. So I look at the diagram. The ground it's G123. And if I look up the component locations, G123 is supposed to be on the top rear corner of the bank 2, the one that's forward in the engine. So it literally should be staring me right in the face. And so I look down, and I've done a number of jobs on these 3/6s, so I know the ground they're talking about. And I look and I don't see it there. There's a bulge hole and what looks like maybe a ground used to be there, but there is no ground strap. And I look at the harness, a good 6 inches in every direction, and I don't see like a ground strap just hanging there. That's kind of what I was expecting to see. There's nothing there. I was like, well, that's very strange. Maybe this diagram's wrong. I don't know. But like I said, it kind of looked like there was a ground there at one point or another, but I don't see anything. And I asked the tech too. I'm like, hey, do you remember there being a ground at that point. And he's like, I'm not sure. He's like, I know that is usually where they are on the 3.6s, but I don't recall exactly on this one. But he did mention, he's like, there are several grounds on a stud that are below the oil filter housing, kind of behind the exhaust, in front of the starter, below the oil filter housing on these 3.6s. So same side of the engine, but down below. And so I still have my headlight bulb connected to this ground wire at the coil, and I have it powered up on the other side. So it was kind of tough to see under the exhaust and the oil filter, but I could see the grounds that he was talking about. So I reached down there and I just started wiggling that harness. I just want to see what happened. And I see my light bulb light up. And I'm like, okay, all right, now I know where we're going. We just have to figure out. And we look down in there and everything seemed to be attached. There was the big cable from the battery and then three other eyelets that were bolted down, and they all seem to be tight and connected. And we're looking. And as we're looking down in there, we actually took off the oil filter. We could see there was another eyelet that was off behind the AC compressor, just kind of hanging there. And as soon as I touched that to ground, my headlight lit up. And so we connected that up, got everything back together, and this thing started up. Now, what's very strange about this is that's not where this ground is supposed to be. And I'm really not sure why it was down there. And I asked him, well, maybe this thing came out. Did you swap harnesses? And he didn't really give me a clear answer on it. And so according to the diagram, that ground should not have been down there. And it didn't look like the harness was manhandled to get it into that spot. It just seemed to be in a different spot. I looked around on diagrams for these Impalas or these 3.6s, a couple years down, a couple years up, to see if the ground was in a different spot. It didn't show it, but I also didn't put in a ton of work to try to figure it out because it started and ran at that point. And I think that's why it ran at first, is because that eyelet was touching for a little bit and then it moved off of the compressor and no longer had ground for those components. So a loose or missing ground, if you will, fixed this. We had some questions about the harness, but either way, at this point, it starts and runs. I did my part. I'm moving on to my next vehicle. So good to go with a ground attached. The thing to keep in mind there is when you're checking for grounds on a circuit that's doing some work, right, like a coil, we need to make sure that that circuit can handle a load. And I always say, I think about circuits differently depending on what they're meant to do. If it's that little 5-volt pulse from the computer for the trigger for that coil, I'm not so concerned if it can handle a headlight bulb, but the actual ground supply to the primary winding of that coil, yeah, I want to make sure it can handle some load. Let's put a headlight bulb or even something bigger than that to make sure that the circuit can actually handle that load. So keep that in mind, because my test light did light up on that ground. And had I just left it at that and not really pursued it anymore, I might have missed the fact that it was open. Now, the one thing was like, how did my test light up there when the ground was disconnected? I'm wondering if other things on that circuit were allowing my test light to light, or potentially maybe it was making small enough contact down on that compressor to light my bulb. I'm not really sure, because once I moved the harness around, I kind of disrupted everything. But anyways, we found out what was wrong with it and got that one going.
This episode is brought to you by autorescuetools.com and Isaac Rodell. If you're looking for scan tools, key cutting equipment, programming laptops, Isaac is the guy. Not only does he have an extensive list of all of those things I mentioned, his support after the purchase is top notch. I bought my Dolphin key cutting tool from Isaac several years back, and he has helped me out every step of the way. Anything that I needed on this thing, I didn't quite understand. If I had an issue with it, I needed something additional, he was easy to get a hold of and helped me out with that. So I highly recommend that you check out his website if you need anything related to keys, scan tools, diagnostic equipment. And again, that's autorescuetools.com. The link will be in the show notes. This episode is brought to you by autorescuetools.com and Isaac Rodell. if you are looking to get into module programming, but you are not sure what kind of laptop you're going to need or how to set it up for programming, Isaac is your guy. He can set up laptops specifically to do control module programming for specific brands with partitioned hard drives and all the software that you're going to need to do this. He also sells key cutting equipment, scan tools, and other diagnostic equipment. I bought some stuff from him in the past, and the support is phenomenal. So I highly recommend checking out the website. Again, that's autorescuetools.com. The link will be in the show notes.
Got that one going. All right. So second vehicle the same day. This was the 2017 Ford Escape with a 2.0 EcoBoost. And this was also a motor swapped with a used engine. It is now a crank no start. The shop said it did run before the swap, but it had coolant leaking into the combustion chamber. And that's a big deal on these Ford Escapes and doing motors in a lot of cases. I don't actually know if the 2.0s have the same problem as the 1.6s where the block cracks, but they elected to do an engine at this point. Okay, that's fine. It has not started at all since the engine swap. And this one was interesting actually because the technician that did the work quit working at the shop. And so this other poor guy is trying to sort through what the first guy did or didn't do. And they're kind of at their wits' end at this point. Right. And so, you know, he understands where I'm coming from. I understand where he's coming from, where you're walking in blind in a lot of cases because you don't know what was done or not done or what was missed or the mindset. Hey, I'm out of here in a couple of days, or maybe he just walked out pissed. I have no idea what the scenario was, but I wasn't able to talk to the person who did the work is the sum of that. So anyways, I'm going to take my same approach. I'm going to do my full vehicle scan, and it actually ended up being the same scenario. I don't have any codes in my ECM. No, there's nothing. There's nothing pointing to why an engine's not starting. I'm going to look at very similar data PIDs to the Impala. Only difference being is this is a speed density engine, so I don't have a mass airflow sensor. But I'm going to look at engine RPM. I'm going to look at fuel pressure, temp sensors, camshaft data PIDs, anti-theft status, right? A lot of the same stuff I'm going to be looking at. I have engine RPM during cranking. It's about 200 while I'm cranking. Fuel pressure looks good. I had about 1300 on the high side. So I have adequate fuel pressure for this thing to start. And again, they said it ran beforehand because, you know, one of the things that I've seen vehicles sit for a long time, maybe they get contaminated fuel, water in the fuel, something like that. And the shop didn't realize that beforehand, that it didn't run. You can have problems like that. I'm not so much thinking that here because they said it ran when it came in. Anyways, temp sensors, everything reads about room temperature on this thing. There are camshaft sync PIDs on these Fords, and they're about 3 or 4 degrees of variance, but they're right on the money as far as what I want to see for this thing to start. The anti-theft status says that it's allowing fuel. Now, timing on these little Ford turbo 4-cylinders, not even just the turbo ones, a lot of the Ford 4-cylinders is a really big issue, especially after an engine's just been installed. Also, if they've had it apart for any reason, but there are so many different ways that these engines can be out of time. The crankshaft pulley itself, and this is a big one for engine installs because it's not keyed. And so if you take it off to get the motor in or out and you put it back on and you don't use the alignment equipment, there's a good chance that that crankshaft pulley is going to be off in reference to the crankshaft. And the crankshaft sensor actually reads off of the balancer, right? So if the balancer's off, you're telling the computer the completely wrong thing. Now, here's the other thing is the timing chain gear itself is also not keyed to the crankshaft. So if there's any rotation of the engine when you have that bolt loose for the crank pulley, you can be out of time there. Now, if you've gone into the engine in any way, obviously you can have the timing chain off. The phasers are not keyed to the camshafts, so you can have the camshafts off. You have to use all of the specialty tools for these things. There's a bar that goes to the back of the camshafts that lines those up. There's a tool for the phasers. There's a pin for the crankshaft. You got to use all that stuff, and you got to use the right one. You can use the wrong length pin for these crankshafts because there's different Ford engines, and it'll put it out of time. So there's so many different ways that you can have these things out of time, and I'm strongly considering that as I get into this. But so far, I don't see any immediate indications that this thing's out of time. Again, I'm going to listen to this along with looking at my scan data, but I'm going to listen to this as it's cranking and see, do I have any noticeable compression issues? Now, the interesting thing on this one was it was cranking, and I kind of noticed it was cranking. It just seemed a little slow, like not terribly slow. The battery was discharged when I got there, so I had my jump pack hooked up, and I got a pretty strong jump pack, but this was the end of the day. I'd used it a couple times. I didn't think much of it, but I did just kind of notice, like, this thing's cranking a little slow. And it's about 200. So, I mean, same as the last one I did, but this is a little 4-cylinder. And I think these things normally crank just a little bit faster. Again, I didn't think time, but I did observe it, I guess you could say. But again, my PIDs that I can see in the scan tool all look like they're about where they need to be. Cranking fuel is allowed. There's actually a PID that says cam and crank sync. It says yes. I'm not going to, take that as everything, right? It's the same thing. It could be a false negative, right? Just because my scan tool data PID cranking says, I may still need to look at the timing of this engine, but I'll keep it in mind. So now I got to move to the engine for testing and do some actual tests. And I could kind of smell fuel on this thing while it was cranking, which doesn't mean a whole lot, but I could smell something. And I kind of want to test for spark, but also I cannot get out of my head the timing thing, just because I've seen so many of these have timing issues, especially after engine installs, and it's a used engine. So it could just have an engine timing issue anyways. Now I have noticed, at least on the 1.6s, if they're far enough out of time, they will spark once and then they'll stop. And that's Nissan's done that. There's other manufacturers that have that as well. Is if the computer can't figure out the correlation between the cam and the crank, it just gives up after that initial one spark event. So not only am I testing for spark, but I'm kind of testing spark to see, do I have that scenario that's going to lead me to a timing issue? But because I'm kind of stuck on this this timing thing, like I really want to get this out of the way, I'm going to do cam and crank at the same time. Now, if this was another engine, that might not be my way to go. I'm doing this based off previous experiences with these Ford Escapes, and I just want to get that completely out of the way. So I got my 4-channel Pico. Two leads are going to be hooked up to the cam sensors. One's going to be hooked up to the crank sensor, and the other one I'm going to use the blue coil wand and just put it over number 1 coil, and we'll see what we get. Okay, so crank it over and watch my scope. First thing I do is get the cam and crank waveform, line up the 2 camshafts, and on these things and the 1.6s, the cams are almost right on top of each other. They're offset just a hair, but they're very close together. And then you can take a known good and line it up with the missing tooth on the crankshaft. And there's a certain spot in there where they're about 5 teeth apart from the missing gap. And so I pick that on mine. And then I also look at a known good, one that has no issues. And I look at the timing in reference to the missing tooth on the crankshaft. And I count my teeth over and I look at mine, I look at the known good. They are exactly like dead nuts on perfect from one to the other. Okay. So based on what I'm seeing here, I don't see a timing issue. And I mean, I was kind of in my head expecting to find one, but I guess it's a good thing that now I can kind of leave that alone. Say, hey, there does not appear to be a timing issue. Now, I'm still thinking that the crank could be maybe off because, again, you can have the crankshaft because it's not keyed to the balancer or the gear, that you could actually have the pistons in the incorrect position. and the balancer and the camshaft's reading correctly. And that's a weird scenario, but it could happen. And I've actually seen that on the escapes. It'll cause detonation on acceleration because the piston's in the wrong spot. And you don't get any timing codes because as far as the engine computer is concerned, it sees the right timing. But anyways, the timing between the two is right. Now, I did notice one other thing while I was looking at my waveform. And so I have my two camshaft signals, and those look pretty good. I was also measuring for spark. Now I noticed there is no spark, and I moved my coil wand around a little bit, and I didn't see any. And I was gonna go to checking the powers and grounds and stuff with the coil, kind of like the Impala, but there was something else about the waveform that it stood out to me. And this just comes from doing a ton of cam and cranks and looking at a lot of waveforms and a lot of vehicles with my Pico. Like, I know how it works. I know what I should see. I know when something stands out, it's very obvious. Now, if you're watching the YouTube video, you can see this. And if not, I'll try to describe this the best that I can. But my crankshaft waveform, number one, the peak voltage was way off. I mean, it was only about a 1 volt at the peak. And then it actually went negative below 0, which I thought was weird. And it also had a really wavy pattern. And it almost looked like a relative compression waveform, honestly. It just really, really odd. And immediately when I saw that, I'm like, oh, I must have not clipped my ground, right? The black part of the scope lead. I must have not clipped that correctly. And I was just using the engine block. And so I move it around to a couple different spots, and I can't change that waveform. My camshafts look good. Now, my camshafts, they're on the back of the engine. I'm using battery negative for those two leads, but I'm using the engine block for my crankshaft. And I can't change this lead no matter where I put it on the engine block. There's just, again, it looks like a relative compression waveform with the little teeth for the crankshaft. And I could line it up, right? I could still see my missing gap. But it looks like mountain peaks at the top of this waveform when it should be a flat, and I'm pretty sure 5 volts, and it ain't there. So something's up here. And now I'm considering, is there some sort of voltage drop issue to the engine block, right? So when I moved the ground lead for the crankshaft, I had to use a jumper wire because of where the crankshaft sensor is. But when I moved that to the negative battery, it actually looked normal. It looked flat. So something was up with the ground on the block for the engine. And now I need to move to doing a voltage drop test between the battery and the ground or the engine block, right? And so I've got my scope out, and all I did was I took one of my camshaft leads and I took it out of the camshaft. I put one side of the lead, right? So imagine you got a scope lead, it branches off into the colored part and the black part, okay? So I put the black part on the negative battery and I put the colored part on the engine block, right? Just clicked a metal spot on the engine block and I clipped it to it, and I went and I cranked the vehicle over. And I've got about 4.5 volts of voltage drop between the negative terminal and the engine block while it's cranking. And it actually peaked much higher, peaked up at like 9 volts when I first hit the starter. And it looks like a relative compression waveform, right? It's following battery voltage, essentially. And it also matches up perfectly with the waveform I'm seeing in my crankshaft sensor when grounded on the block. And so I know I have an issue. I got a big voltage drop issue. Okay, I just got to find the ground path between the negative terminal of the battery and the engine block. And I'm looking around and I'm looking around and I'm looking around. And I'm like, I don't see a ground cable on this engine anywhere. I'm looking underneath and whatever. I like, you should be able to see a big cable going to, I'm assuming, somewhere on the transmission side of things, but I don't see anything. And so I go to service information because it seems really odd that I don't see any cable at all. And it was actually not an easy task, but I did find a diagram, and I actually found this on RepairLink Shop. But I found a diagram, and again, if you're watching the YouTube video, there's a red cable that goes from the transmission bell housing to the frame of the vehicle. And if you look at the battery, on the battery, the negative cable actually goes over to the frame, and then it goes frame on a different cable. It goes frame to transmission case. And so where that is in the diagram, I go to the car, there's nothing there. Now, you can see on the frame where there was a cable, right? There's a bolt hole. There is a witness mark from the cable being there for a period of time. And there's the little slot where the tooth on that eyelet will go to keep that eyelet stationary when you tighten down the bolt. But you can tell it was there. It is not there. And I look on the transmission side of things. It's not there. It's gone. I asked the techs that were there. We look around the shop. They didn't have the old engine anymore. They sent it back. Of course, every place just always sends everything back before they're done. We couldn't find this cable. So I showed them the repair link thing. I'm like, hey, this is what you got to tell a Ford dealer. You got to get a cable. And I proved this. I just took my jumper cables, like actual jumper cables to start a vehicle. I clipped it on the negative battery terminal. I clipped it on the block. I hit the key. This thing fired and up immediately, ran. And it seemed to run good. I shut it off. I didn't run it very long because I didn't know, what they had not disconnected or not connected. But I was like, that's all you got to do is get this cable. It's just gone. It's missing. Now, the crazy thing was this thing was cranking and there was no ground cable going to the engine block or transmission. Now, my guess is it was grounding through the mounts, but that obviously wasn't enough. Now, if you remember back a ways, I had a Ford Fiesta that we had some really weird cranking issues. And it was same thing where the starter was working. It was turning the engine over, but there was enough voltage drop on the transmission case that the TCM was dropping out and keeping the ECM from cranking because of the park neutral position. Now, this one is a little different. This voltage drop, and I didn't look too far in the diagrams, to be honest, but I think the ECM also had a ground at the block, and I'm pretty sure the coils ground on the block, a lot of stuff grounded on that block, and that voltage drop was enough to just kill everything. And I mean, it was immediate. As soon as I hit the key afterwards, this thing fired right up. So again, I didn't look in too far to see exactly what I was what I was missing or what ground really affected this thing to not start. But I thought it was really interesting. The starter still operates, but whatever other component is on grounding on that block electrically was not able to do its job. So really, really interesting, because if you had said, hey, I didn't put on the ground cable from the battery, from the frame to the transmission, is this thing going to crank? I would say no. And I've seen that before where people just leave ground straps off. It doesn't crank. Oh, you have voltage on your block. Okay. But this one had enough of a ground path, I'm assuming through the mounts, maybe the exhaust, but I don't think so, that it was able to crank over. So really, really weird. But anyways, that's all I got for you today, is those two case studies. So hopefully if you're doing an engine out there, you're connecting all of the ground connections and not throwing away straps or not quitting the job before it's complete. But anyways, just want to say thank you for listening. Thank you for all the feedback on the show. If you got any ideas for the show, you want to be on the show, hit me up. You'll see my email in the show notes. The Facebook group is also in the show notes. You can probably message me on Facebook as well. And again, check out that YouTube channel if you haven't. Oh, and leave a review for the podcast on Apple or Spotify. Leave a comment on YouTube, and you'll be entered for a chance to win an Automotive Diagnostic Podcast t-shirt. If you want to purchase a t-shirt or sweatshirt, let me know, and we'll get that to you. But with that all out of the way, let's get out there, start fixing the world one car at a time.